Number 77. During heavy lifting, a disc between spinal vertebrae is subjected to a 5,000 Newton compressional force. What pressure is created assuming that the disc has a uniform circular cross-section of 2 centimeters in radius? Right, so letter A right there, asking for pressure, they're giving us force, and they're telling us area essentially. So let's use this formula over here. Pressure, right, will be equal to the force applied divided by the area over which that force is applied. So we're asked to find for pressure, so we can leave this alone, right? So we need force in newtons and area in square meters. Now, what type of cross-section is this, right? So here's the vertebra. Okay, it's a disc, and it says that there is a 5,000 Newton compressional force. So why don't we just create like a little, here's the disc again, right? It's looks kind of like that. That's cool. Looks almost basically cylindrical, right? So this disc has a certain radius, all right? And the radius here they told us was 2 centimeters. I'm just going to convert that to meters right away, 0.02 meters, okay? And there is some compressional force, meaning some force pointing directly down. All right, and that force is going to be 5,000 newtons. So to find the pressure, okay, over this circular cross-section of the disc, I need to know the force applied to that cross-section, that area, and I need to know the value of the area. Okay, so since it's circular, what's the formula for area of a circle? Pi r squared. And now we should have everything we need in order to calculate, right? So here, the pressure is going to be equal to the force applied divided by the area over which that force applied. And that area, since it's circular, is going to be equivalent to taking pi and multiplying it by the radius of that circular cross-section squared. I got everything I need now, right? Got everything I need, just plug it on in. I don't really know where that came from, but whatever. Okay, that's what happens when you do physics problems most of the day. You start to lose it. So the radius here is going to be 0.02. All right, so 0.02, and that's squared. So just calculate now the pressure. So there's going to be 5,000 multiplied by, not multiplied, whoops, 5,000 divided by now, in parentheses, pi times 0.02 squared. I'm going to value here, big pressure, right? This is about 3.98. 3.98 times 10 raised to the 3, looks like 6, right? Hopefully my eyes are not mistaken. So 3 times 10 to the 6, and this is in terms of pascals, okay? So this will be the pressure that vertebra is experiencing. All right, then part B. So it says, what deformation is produced if the disc is 0.8 centimeters thick and has a Young's modulus of 1.5 times 10 to the 9 newtons per meter squared? Wow, now that's a blast from the past, huh? All right, so let's do Young's modulus. So let's do letter B. Fortunately, I have the equation right over here. All right, so what, if you remember, which variable in here represents deformation? Deformation kind of means like change, right? Change in shape, okay? Change in size, change in length, something along those lines. So this is the deformation, all right? Delta L. So in order to find the deformation, let me take this equation, solve it for delta L. All right, so I'm just going to write it down. F is equal to Young's modulus multiplied by the deformation divided by the original length of the object multiplied by the area, okay? Cross-sectional area, that is. So, again, solving for delta L, right, we can think about this actually very simply. This is essentially Young's modulus, right, and that's over 1. This is area, and that's essentially over 1. So when you want to solve for delta L, that's already in the numerator on the left-hand side, so just leave it there, delta L. Now, also F is on the right-hand side, the left-hand side. What's my left? I don't know. This is on the left-hand side, and that's already there, so I'm not going to touch this. All I need to do is get rid of Y, A, and Li. So what I need to do is I need to essentially switch all of their spots. So if Young's modulus is in the numerator on the right, it's going to be in the denominator now on the left. Okay. If area is in the numerator on the right, now when it comes over, it's going to be in the denominator on the left. And then if the initial length is in the denominator on the right, it's going to come up and work its way into the numerator on the left. So Li. So here's the formula. That's it. Okay. And now all we got to do is just plug in the values because we know everything, right? That sounds kind of conceited, but I didn't mean it that way. All right. I don't know everything. We know all the variables here. Okay, that's about all we know. So in terms of the initial length, they're talking about the vertical height. Okay, so that this length is essentially the vertical height. They told us it's 0.8 centimeters thick. Again, we need to have this in terms of meters, so just take this value and divide it by 100. So I'm just going to leave it 0.800 over 100. That's the value now in meters, okay? And now let's just plug it all on in. So here we have 0.800 over 100, okay, multiplied by then the force applied, which they told us was 5,000 newtons. And this whole thing now divided by Young's modulus, they gave it to us, 1.5 times 10 to the 9. And then that's going to be multiplied by the area. Here's the area that hasn't changed. It's going to be pi 0.00, come on, 0.02 squared. All right. And that's going to equal delta L, the deformation. Let's plug it on. So 0.8 divided by 100 times then 5,000. Then divide this whole thing by now 1.5 times 10 to the 9th times pi times then 0.02 squared. Close those parentheses. And we get now a deformation of 2.12. Okay, 2.12 times 10 raised to the 5th. Negative 5th. Well, that would be that wouldn't make any sense, right? How could it be? How could it have compressed 200,000 meters when it is only that big? It wouldn't make sense. So it's times 10 to the minus 5. That's in terms of meters. All right. If you had to convert that, into millimeters, take that and divide it by 1,000. All right. You're talking about hundredths of a millimeter. So, yeah. So there you go. All right, guys. So thanks so much for tuning in. Appreciate it very much. Hope this helped. Please remember to help us out and subscribe and hit that like button if you can too. We appreciate it very much. Bye-bye.